Welcome to Sky Night Narratives. 120 light-years away, orbits a world unlike any in our solar system. K2-18b, a Hycean planet, larger than Earth, potentially covered in vast, deep oceans beneath a thick hydrogen atmosphere. A prime candidate in the hunt for alien life. Earlier studies, using the James Webb Space Telescope, hinted at Dimethyl Sulfide, DMS, a gas on Earth produced almost exclusively by life, primarily marine plankton. The excitement was palpable, but caution remained. Could unknown geological processes mimic this biosignature? But now, further analysis, deeper observations released just weeks ago, reveal something far more complex, something impossible to dismiss. JWST hasn't just confirmed DMS. It's found an entire cocktail of atmospheric gases coexisting in ratios that defy standard geochemistry. Not just one potential sign of life, but a chorus of them. Oxygen, methane, DMS, perhaps even more complex hydrocarbons, all present together in a specific, highly unnatural balance. This isn't just the signature of simple microbes anymore. This chemical fingerprint, this impossible atmospheric blend, points towards something far more complex. A global biosphere, perhaps even macro-level life, actively regulating its planet's atmosphere on a massive scale. Forget hints. Forget possibilities. The data pouring back from K2-18b might be the first irrefutable evidence of a complex, thriving alien world. The biggest discovery in history isn't a maybe anymore. It might already be here. If K2-18b is truly alive, teeming with complex life, the evidence isn't a single smoking gun. It's the entire atmosphere screaming anomaly. A chemical composition so bizarre, so far from equilibrium, it defies explanation, unless you invoke biology on a planetary scale. This is the case file on the impossible air of an alien world. First, the dimethyl sulfide, DMS. That tantalizing hint is now confirmed with high statistical confidence by the latest JWST spectral analysis. But it's not just present, it's abundant. Far more abundant than any known abiotic process on a Hycean world could plausibly generate. On Earth, DMS is overwhelmingly produced by marine phytoplankton. Finding it in such quantities on K2-18b is already staggering. But it's only the beginning. Here's where it breaks geochemistry. JWST is detecting significant amounts of both methane, CH4, and oxygen, O2, coexisting in the atmosphere. These gases are highly reactive with each other. In the presence of UV radiation from the star, they should rapidly destroy each other, reaching a very low equilibrium level. Finding both in large quantities simultaneously implies a massive, continuous source for each gas, constantly replenishing what's being destroyed. What natural process could do that? Life, specifically photosynthesis producing oxygen and methanogenesis producing methane, does exactly this on Earth. For a planet thought to have vast oceans, possibly interacting with a rocky mantle, we'd expect a significant amount of carbon dioxide, CO2, in the atmosphere from volcanic outgassing or ocean chemistry. Yet, the new data shows CO2 levels are surprisingly low. It's as if something is actively removing CO2 from the atmosphere on a massive scale. Again, on Earth, large-scale photosynthesis, particularly by vast forests or algal blooms, is a primary mechanism for drawing down CO2. Is K2-18b's biosphere actively regulating its climate? Beyond the simple gases, JWST's sensitive instruments are picking up faint, but persistent, spectral signatures suggesting more complex hydrocarbons. Things like ethane, C2H6, perhaps even hints of heavier organic molecules. While trace amounts might form abiotically, their presence alongside the specific cocktail of DMS, methane, and oxygen creates a chemical picture strongly suggestive of complex biological waste products or atmospheric processing by a diverse ecosystem. DMS confirmed, methane and oxygen together, low CO2, complex hydrocarbons. This isn't just one biosignature, it's a network of them. What's your gut reaction now? Tell me below. And the final piece, the human element. The initial DMS hints caused excitement, but this new data, this impossible cocktail, reportedly threw the astrophysical modeling community into chaos. The results were so far outside standard models that the public release of the full dataset faced significant delays. The official reason? Extensive model recalibration required, eliminating all potential instrumental artifacts. But insiders whisper of heated debates, disbelief, and perhaps even pressure to downplay the biological interpretation until every conceivable, however unlikely, abiotic explanation could be exhausted. Is this rigorous science? Or the institutional inertia, the fear of announcing the single most profound discovery in the history of everything? The data isn't just speaking, it's shouting, and the silence in response feels telling. So, the atmosphere of K2-18b, 120 light-years away, looks chemically impossible. Abundant DMS, methane and oxygen coexisting, vanishingly low CO2, traces of complex hydrocarbons. This isn't just one anomaly hinting at life. This is a full-blown symphony playing a biological score. If this isn't the signature of life, then our understanding of planetary chemistry is fundamentally broken. This forces us beyond the search for mere microbes. The data, the complexity of this atmospheric cocktail, compels us to consider possibilities previously confined to the wildest dreams of science fiction. This is the biological conclusion, taken to its logical extreme. Forget simple slime. The combination of gases, particularly the methane-oxygen paradox and the low CO2, suggests not just life, but a complex, globally significant biosphere actively regulating its planet. Imagine vast alien oceans teeming with organisms analogous to phytoplankton, pumping out DMS and oxygen, perhaps continents covered in strange hydrogen-breathing vegetation, consuming CO2, perhaps even complex animal life contributing methane and other trace gases through metabolic processes. This isn't just a habitable world. The data screams. It's an inhabited world, a living, breathing planet, with an ecosystem potentially as complex, or even more complex, than Earth's. We might not just have found life, we might have found Genesis 2.0, but could nature, under truly alien conditions, forge the ultimate illusion? Hycean worlds, massive water oceans beneath thick hydrogen atmospheres, are environments unlike anything in our solar system. The pressures, the temperatures deep below, the unique chemical interactions between a hydrogen atmosphere and a water ocean under intense stellar radiation. Could they create novel abiotic pathways that produce this exact, bizarre cocktail of gases? Imagine extreme geological processes deep within the planet's mantle, interacting with the ocean in ways we can't model, releasing precisely the right mix of chemicals to mimic a biosphere. Perhaps DMS can form abiotically under such conditions. Perhaps unknown photochemical reactions in the upper atmosphere maintain the methane-oxygen imbalance. In this scenario, K2-18b isn't alive. It's a planetary-scale chemical engine, a Hycean crucible operating under physical laws pushed to extremes, creating the perfect chemical counterfeit of life. It would be a discovery rewriting planetary science, but leaving humanity, still tragically, alone. A thriving alien biosphere, or the universe's cruelest chemical trick. The answer, carried on photons that have traveled for over a century, holds the weight of everything. The stakes? Reality itself. Finding simple microbes elsewhere confirms life isn't unique, but finding a complex biosphere, a world actively regulating its atmosphere with multiple interlocking biosignatures like K2-18b suggests, that's different. That implies that complex life, perhaps even intelligent life, isn't a 1 in a trillion fluke. It implies the universe is designed, or at least primed, for complexity. It means we are not special. It means the cosmos is likely filled with living worlds, perhaps even civilizations, far beyond our current detection limits. Forget comparing this to the discovery of fire or the splitting of the atom. Confirming a complex biosphere on K2-18b would be the fulcrum point upon which all of human history, philosophy, and our future pivots. It's the end of loneliness, but the clock is ticking. JWST is a miracle of engineering, but it has limited time. Observing time on this telescope is precious, fiercely competed for. We need more data, longer observations, different wavelengths. We need to confirm these tentative signals beyond any shadow of a doubt. Atmospheres change. Stellar activity can interfere. Instrumental artifacts must be ruled out with absolute certainty. We are potentially looking at the greatest discovery ever made, based on flickering shadows in starlight from 120 light-years away. The race is on, to gather irrefutable proof, to convince a skeptical world, to dedicate the resources needed to stare, unblinkingly, at this potential Genesis 2.0 before the opportunity or the funding fades. We may have just found everything we've ever searched for. We cannot afford to look away now. Follow-up observations are being scheduled. The data is under intense scrutiny. Make sure you're subscribed with notifications on, because the official confirmation or refutation of complex life on K2-18b could redefine our universe. So, K2-18b, 120 light-years away, a hazy world, potentially covered in oceans, breathing an impossible atmospheric cocktail. Is this the smoking gun? The irrefutable proof that complex life is not unique to Earth? Whether it's a teeming global biosphere actively terraforming its own world, or just an unbelievably complex chemical engine mimicking life with cruel precision, the implications are staggering. It suggests the potential for life, complex, pervasive life, exists on a scale far grander than we ever dared hope, or perhaps feared. If K2-18b is alive, then the cosmos transforms from a vast, lonely desert into a teeming jungle filled with hidden oases, countless cradles of Genesis, waiting to be discovered. Earth becomes just one note in a potentially infinite biological symphony. If this glimpse into a potentially living alien world expanded your perception of the possible, support Sky Night narratives by hitting that like button. But now, the ultimate question resonates across the light years. The Sky Night narratives community. Based on this atmospheric cocktail, what do you believe JWST has found on K2-18b? Is it definitive evidence of a complex alien biosphere, or the universe's most elaborate chemical illusion? And here's the thought that truly takes us to the edge. If complex life is thriving on K2-18b, what form could it take in that hydrogen-rich, high-gravity, watery environment? What wonders or horrors might swim in those alien oceans? Drop your most imaginative theories about K2-18b's potential ecosystem in the comments below. And share this video with someone who thinks finding aliens means finding little green men. The reality might be far stranger and far more abundant.